We're going to write this system of equations, in augmented matrix form. Notice when we say a system, we mean that group of equations that have the variables, the letters. Whereas this one doesn't have any letters, no variables. It's easier to work in this form because in the system of equation form, you're going to have to be writing the variables over and over till you're done. This one, you first remove the variables, work with the numbers, and then put the variables back on. So this is called an augmented matrix form. Notice that we just took the numbers in front of the letters and put them here. This line is the equal sign, and these constants are right here. These numbers in front of the letters are called coefficients. So these are the coefficients of the system, and these are the constants. Now change into row echelon form. You say, well, what's row echelon form? What does it look like? Here's an example of what row echelon form looks like. This is the main diagonal, the one that comes from left to right, comes down. It's the main diagonal. And then the off diagonal elements, locations, we have zeros. Once you have this form, it's very easy to solve. Very easy to solve. So here's our problem. The one we had at the very beginning, the one that we got from the system of equations. And this that you see here, this is the plan. This is the work we're going to do to get zeros here and later on ones right here. So R stands for row. The subscripts are the rows. For example, row 1 would be this one, row 2 would be this. So we're going to multiply row 1 by -2. And the reason is that we need a -2 here. So when we combine these two numbers, it turns into a 0. So multiply row 1 by -2, then add it to row 2, and then replace row 2. When we do the replacement, we get the 0 here. So this is the plan. Now we're going to carry it up. So it's -2 times each of the members of row 1 times multiply distribution. This is what you get. This is the product. Now it says here that I should add row 2 to it. So I just slide row 2 underneath it, and I combine these terms. Notice we have our 0 right here. This is 0, and this adds up to -6. We're going to replace row 2 with it. So we replace it. Now if you put the variables back on, this was the x, this is the x column, and this is the y column. Put the constants back on. And the variables, notice we're putting back the variables. This last one gives you 0 equals -6. That's not true. Not true. So we say there's no solution. In other words, if you were to draw these two lines, they wouldn't intersect. They're parallel lines. Here's another example. We're going to try to accomplish the same thing. So here's a system. Here's our augmented matrix. Now we're going to try to get the zeros here and the 1. So we do the row operations. We say we're going to multiply row 1 times -2. Because I want a -2 here. So -2 times all of row 1, then add row 2 to it. So here is row 1 being multiplied by -2. Here's the product. Now we're going to add row 2 to it, and we get a 0. So you go down the columns, combining like terms. Now we're going to replace, we said from the beginning, row 2. So this row 2 is going to become the new row. This is the new row 2 for this row. It's beginning to take that form. It's the echelon form. Now we're here. So we have to continue. Now we're going to get a 0 here. So if I had a negative in one of these and then added them up, my 0. So I'm going to pick row 2. I'm going to multiply it times -1, the whole row, and then add it to row 1. Here we're going to carry out the plan. -1 times row 2. This is the result. And then we add them, and then this is the sum. This, after the addition, after we add these two, we're going to replace row 1 with a result. So we're right here, we're replacing it. Notice this implies that 0 equals 0. If you were to put the variables back on, it would be 0 equals 0. That's always true. When you see this result, it means there's an infinite number of solutions. So if you're talking about two lines, that means either you have two lines or it's the same line. Infinite number of solutions when you get an always true statement. So a row of zeros implies an infinite number of solutions. Here's another example. We can do exactly the same thing. We write it in Augmented. Here is the plan to get our zeros from 1 to operation. We're going to multiply row 1 by negative 3. Here's the result. Now we're going to add it to row 2. Here's the result. And we're going to replace row 2. Replace it. Row 2 is going to be replaced by this. So this used to be our row 2, but now this is our row 2. We still need it. So now we're going to work to get a 0 right here. So I'm going to multiply row 1, all of row 1 of 5. And then add the result to row 2. And then replace 1. So let's carry out the plan. 5 times row 1. This is the result of the product. Add it to row 2. Now we're going to replace row 1. Right? This is going to be our new row 1. So there's a new row 1. So we have our zeros. That's the hardest part. Getting the 1 here takes like 30 seconds. All you have to do is multiply each row by the reciprocal of the number where you want a 1. So I want a 1 here, so I multiply the whole row by 1. But I have to multiply the whole row by 1. 1/5. Okay, so 15 divided by 5 is 3. I'm going to multiply row 2 by a negative 1/5 so I can get a positive 1. So negative times negative is positive, and negative 5 times negative 1/5 gives you a 1. Then negative 1/5 times negative 20 gives you a positive 4. So notice the row echelon form. Actually, this is in reduced because we have zeros both above the main diagonal and below. So notice you're going to put the variables back on, the letters back on, and this tells you that x should be 3 and y should be 4. This is a unique solution. There's one solution. That means these two lines, if you were to draw them, would intersect at this location.